It's the field trip episode of Hello from the Van. In this episode, we are talking about tides. I recently took my kids on a field trip to the tide pools of Dana Point, California. We had planned our trip specifically around low tide so that we could check out the tide pools and all of the life that abides in them. And how did we know when low tide was? Well, it's all down to math and science. And before we get too deep into that, we need to lay the groundwork for the water works, if you will. We need to understand some basics. The first is physics, specifically Newton's first law of motion. You see, Newton was a fancy scientist that lived in the early 1700s, and he's the person who gave meaning to a lot of the things that we all experience each day, like gravity. He was the one that said, hey, this is a thing, let's learn about it. Newton had some very scientific laws he determined were absolutes for the entire world, and his first law of motion is that an object in motion will stay in motion, and an object at rest will stay at rest. That is, until they're moved upon by another object. This is important when we're understanding waves and tides. Also, it's very important for those of us who wanted to grow up and have magical powers like Matilda. Tragically, Newton's first law is what makes it so that we can't just will chalk and carrots to fly. Tragically. The second law we need to talk about applies to both physics and chemistry. In chemistry, we call it the first law of thermodynamics. In physics, it's called the law of conservation of energy. You don't need to remember either of those names. Okay? Because no matter what you call it, the law exists and it's a thing and, it's not going anywhere. The law is that energy cannot be created or destroyed. It can only be transferred. Let me give you a practical example of this. When you eat pizza, your body transfers the units of energy from that pizza, we call them calories, and turns those calories into energy. Let's say you ate a pizza, then you went to the playground, or maybe you went and rode your bike. Suddenly, you get hot and sweaty. Your body starts to emit heat off of your skin. That is this first law of thermodynamics in action. You turned pizza into energy, then used that energy to sweat, and that sweat heated the air around you, and then that air was then cooled by the air around it, and the cycle continues on and on. It's pizza thermodynamics in action. Both of these laws are especially important when we're talking about heat. You know how hot air rises and cold air sinks? That's the first law of thermodynamics. It's what makes it so that when you go into a house, the top of the house is normally a lot warmer than the basement. It's due to these laws of physics and chemistry. But what does attics and basements, heat and pizza have to do with tide pools full of sea stars and crabs and even the occasional octopus? Well, we're going to get into that. You see, the movement of the ocean is influenced by occurrences here on Earth that are familiar, like heat changes and wind. See where I'm going with this? That's a big part of tides. The changes of temperature are a highway of moving energy. They're a very big influence on the ocean. There's also another influence. It's not just one thing that causes the tides. It's two big things. The first is thermodynamics, but the second requires us to shift our perspective from the gravity of the earth and the laws of thermodynamics to the pull of the heavens. In short, we need to talk about the solar system, specifically the pull of gravity from the sun, the moon, and the earth. 3 weeks ago, we talked about the equinox and solstice and how the seasons are created by the turn and tilt of the earth. Do you remember? And the earth's positioning relative to the sun and the moon and its effect on the way that we experience seasons? The tides are affected in similar ways. Here's what NOAA and the Encyclopedia Britannica have to say about that. Quote, both the sun and the moon pull on Earth's water with a natural force called gravity. This pull creates tides. As the sun, moon, and Earth move in space, they sometimes form a straight line. This arrangement creates high tides that are higher than usual. It also creates low tides that are lower than usual. At other times, the sun, earth, and moon are positioned like the corner of a square. This arrangement evens out the tides. It creates high tides that aren't as high and low tides that are less low than usual. Close quote. Remember that first law of motion, that an object in motion, unless acted upon, stays in motion? In the case of the tides, the object is the water, and the thing doing the acting upon is gravity. And if you think that tides only happen in the ocean, boy, you'd be wrong. But so was I when I started researching, so that's okay. Tides take place in all bodies of water. I know, hang with me on this one. In some waters, the change is so slight that the tides go unnoticed. Tides are easier to see where the ocean meets land, like seacoasts and bays, because there's more water to be acted upon. It's the reason we don't notice tides in small things like bathtubs. It's there. It's happening. We just can't see it. However, when it's something big, like a large body of water, it's easily noticeable. Remember that field trip I took my kids on? In Dana Point, where we went on our field trip, the difference between the highest high tide and the lowest low tide is over 8 feet of water. Where you can stand at low tide would literally drown you at high tide. This is not a small amount of water. But when you put it into perspective for how big the ocean is, yeah, that big of a change makes sense. It also makes sense that when we scale it down, that's why we can't see the tides and the pull of the moon in other places, like a bathtub or a small lake. There are 2 high and 2 low tides per day at any given place. The times at which they happen, however, change from day to day. Sometimes low tide is in the afternoon, and other times it can be in the middle of the night. It all depends on the position of the earth, the sun, and the moon. Other things like temperature and season can lead to extreme tides. Remember that law of thermodynamics? That energy that cannot be created or destroyed, just transferred. Now apply that to something as big and vast as the ocean. The ocean heating up and cooling down requires a lot of transferring of energy, and this also affects the tide. Have you ever seen a pot of water boil and then after the boiling the water line is a little bit lower? Yep, ocean tides are affected the same way. Due to all of these factors, both the pull of the moon and thermodynamics, as well as some very smart scientists who figure it out, we know that the average amount of time between 2 high tides is about 12 hours and 25 minutes. But here's the crazy thing. Even though we've only had these clear definitions for laws of physics and thermodynamics for a couple hundred years, humans have known about the current tides and the pull of the moon for thousands of years. Cities in ancient Mesopotamia were built around the rise and fall of tides over 7,000 years ago. And that leads us into talking about the history of tides. Like most histories we discuss, we don't know everything that they knew. We just know what we have evidence of. So let's talk about the evidence. The earliest remaining evidence that we have for ancient peoples knowing about the tide and its correlation to the moon goes back to a tidal clock from 2500 BC. That's over 4,000 years ago. This clock was founded in Kathiawar, India, and used the pull of the moon and earth to give those using it an approximate time of day. More about that tidal history. There is evidence, albeit controversial in nature, for humanity's understanding of the relationship between the tides and the moon cycles that dates back to at least 2000 BC through ancient megaliths in Western Europe. Basically, we know that ancient civilizations drew the connection between the tides and the moon. But how did they know to draw that connection between the tide and the moon? Well, it's the power of human observation. They didn't have a lot of distractions that we have today, okay? There was no YouTube. There was no social media. There was no Netflix. Also, food wasn't industrialized the way that it is today. Most of human history has been spent in the pursuit of food, and learning to use the tides for sailing, agriculture, and trade was part of survival. When your life and your food and your family depends on figuring something out, you put your energy into it. You figure it out. And here are some of those problem-solving observations that helped ancient peoples. The moon is on a predictable cycle. This is easily observed by everyone in almost the entire world. All it took was a couple seasons of tracking the shape of the moon at night to know that something was up. And as anyone who has lived next to the ocean can tell you, moonlight becomes a very precious commodity. It means you can safely do things at night and along a beach that you would normally not be able to do. So naturally, a full moon meant being able to observe the ocean better at night than when there wasn't one. If you go to the beach around a full moon, you soon discover that there will always be a high tide with a full moon. It's a pretty natural observation to connect the two. The moon and the ocean were both required for agriculture. So how does this apply to us today? Well, visiting tide pools is cool. Modern scientists are learning a lot about how the same gravitational forces that cause the tide also affect human bodies. While the effect of the full moon and subsequent tides on humans and animal behavior was an old wives' tale when I was a kid, new studies are actually finding that we are a lot more susceptible to these gravitational pulls and tides than previously taught. New research is finding that those with chronic illnesses find themselves more susceptible to flares around a full moon. Also, those with seizure disorders may see an increase of seizure activity around a full moon. And so I'll leave you with a quote by Rachel Carson. She was a marine biologist from the early 1900s. She spent most of her life advocating for the ocean, the tides, and nature. Here's what she had to say. Quote, "The winds, the sea, and the moving tides are what they are. If there is wonder and beauty and majesty in them, science will discover these qualities. If they are not there, science cannot create them. If there is poetry in the sea, it is not because I put it there, but because no one could write truthfully about the sea and leave out the poetry." Close quote. I'm Mimi Fotz, and this has been Hello from the Van.